Alrighty, let's talk about linear programming. We're working in section 7.5, and this is exercise 16 from your text. Here's the word problem. I'm going to assume that you pause this video and read through the word problem. I don't think I should sit here and read it to you. Read through it 3 to 5 times and make sure you really understand what it's asking, what you're trying to maximize. You're trying to maximize the score of a test, and what your constraints are. And start to get some ideas about it. We're going to walk through it, so pause the video now. Okay, so you should be back now. The first thing we're going to do with any word problem is define our variables. Let x be the number of computation problems. Let y be the number of word problems. Let z be the test score. And this is going to allow us to get our objective function. If you read the problem carefully, you know what we're wanting to maximize is the test score. And z equals 6x plus 10y because each computation problem is worth 6 points and each word problem is worth 10 points. The next thing we want to do is list our constraints on the variables x and y. X is always going to be bigger than 0 and y is always bigger than or equal to 0 in these types of problems. You can't answer a negative amount of word problems, though you'd probably like to. Our second constraint here is 2x plus 4y is less than or equal to 40. This comes from the minutes. We estimated 2 minutes for each computation problem and 4 minutes for each word problem. So 2x plus 4y is less than or equal to 40. We solve that thing for y, and we get y is less than or equal to a negative 1/2 x plus 10. Our fourth constraint here is x plus y is less than or equal to 12. This comes from the fact that we're only allowed to answer 12 problems for this specific test. We're only allowed to, we got to pick 12 and turn those 12 in. So x plus y is less than or equal to 12. The next step, so after we've defined our objective function and we've listed our constraints, the third step is to graph those constraints. So to do that, I'm going to move over to the writing tablet. So here's our objective function and our constraints. And we want to graph these constraints. Note that the first two, the first constraint and the second constraint, those put us in the first quadrant. So let's start the graph here. Draw it big. There's x, there's y. Let's go up. The first one on the graph is y is less than or equal to a negative 1/2 x plus 10. So that plus 10, let's say we're right here. Let's call that 10. And the fact that's a negative 1/2 x, that means our slope is decreasing. So just sketching something of that nature. Okay? And this is equation 3, or inequality 3. And our fourth inequality here, we got y is less than or equal to negative x plus 12. That plus 12, let's say that's 12. So here's something number 4. And note that the negative x, that slope is negative 1, and this slope is negative 1/2. So we know this, for number 4, that thing is decreasing faster. So it is going to intersect somewhere, an intersection point. And I always do my shading at the end. So we're less than or equal to both of these. That puts me on the bottom of both of these, and that's going to put their intersection point in this region here. And with linear programming, what we always want to know is all these intersection points with the shaded region. So I'm going to call this point A, call this point B, call this point C, call this point D. Okay? We want to figure out what each one of these are. So A is quick and easy. We should know that one. A is over 0 and up 10. B, we're going to do a little work to find that one, so we're going to do that one last, okay? C, that is the x-intercept for line 4. So
If we set y equal to 0, what do we get? That x equals 12. Take your time and do that. So we set, for this one here, if we set y equals 0, we get 0 equals negative x plus 12, and x equals 12. So we get y-intercept down here, that's c, will be over 12 up to 0. And d, of course, is 0, 0. So to find b, we could do this algebraically, but let's do it using the graphing calculator. So let me switch over to the graphing calculator. So the first thing you want to do is you want to find the intersection of two lines, so you enter those two lines into your calculator. And so I've got y1 as a negative 1/x plus 10, and y2 as a negative x plus 12. We want to adjust our window to make sure, so our x-min was 0, I believe. X-max, I think 10 will be good. Scale 1, that's fine. Y-min can be 0, remember, because x and y are greater than or equal to 0. Y-max 10, I believe that will be fine. So you really want to make sure on these problems that you're adjusting your window so that you see the intersection, see everything that's happening. So I should be able to go to graph now, and hopefully we will see the intersection happening here. Very good. Okay, so what we need to find is that intersection point. And to do that, we hit second trace, and that gives us the calculate. And then from there, we want to find intersect, number 5. And it tells us to, what's the first curve? Yeah, so it's on the line, so we hit enter. Second curve, it's on it. And then it says to guess, and you can usually just hit enter 3 times here for the most part. So we have an intersection at 4 and 8, and that is the point we're looking for. So now let's go back to our work. So back to our graph here, what did we find? We found the point B equals 4, 8. Now what linear programming tells us is that we maximize and minimize our function at one of these corners. So there are infinitely many points inside here that we would have to check, but someone proved back during World War II that we only actually have to check these corners to find the maximum and minimum for our function. So let's go down and plug these points A, B, C, and D into our objective function, and whichever one gives the highest value, that will be what maximizes our function. So what was the objective function again? Z equals 6x plus 10y. So Z equals 6x plus 10y. Erase that. So that's our first point, over 0 up 10. So A, which equals 0, 10. This implies that Z equals 6 times 0 plus 10 times 10. So 10 times 10, which equals 100. So B is 4, 8. This implies that Z equals 6 times 4 plus 8. Oops. 8 times 10. What's that going to be? 80 plus 24. So 104. C equals 12, 0. This allows that Z equals 6 times 12 plus 10 times 0. So this equals 72. And D equals 0, 0, which implies that Z equals 0. So now we know the answer. We know at the point B that if we answer 4 computation problems and 8 word problems and get them all correct, that maximizes our score at 104. We'd want to state that. Therefore, to max the test score, we should answer 4, yes, 4 computation problems. And 8 word problems for a max score of 104. Alright, and that finishes that problem up. I hope this helps you out.